Good morning, 你好. Welcome to Blockchain and Lindy Chen channel. My name is Lindy Chen. Today is 20th December 2019. I'm very excited to be here and share my insight and about blockchain with you. Yesterday, I shared with you the genesis of blockchain. Today, I will share with you the blockchain terminology. Just like when the internet and the World Wide Web came into being, a whole new language emerged to describe the new technology, processes, and systems. Similarly, the new and emerging blockchain technologies bring with them a range of systems, processes, and elements that are unique and therefore had no existing language to describe them. Through this course, we will be using what is becoming the language of blockchain. It is also reasonable to expect that new language and terminology will evolve that is not covered in this course. However, we will use the foundational terminology that is current at the time of writing and should hold true. Blockchain. A blockchain is a digital ledger in which transactions are made and are recorded chronologically and publicly through distributed peer-to-peer networks. A well-designed blockchain stores transaction records in blocks that are linked to one another using a cryptographic technique that creates the digital distributed ledger. The ledger can be shared and verified by anyone who has access, eliminating the need for costly third-party verification. The cryptographic signature on each block links to the previous block, forming the blockchain, and in a way that makes the blockchain virtually tamper-proof after the blocks are created and appended. Nodes. Nodes are individual computers that make available their resources, including processing power, storage, capacity, data, and even network bandwidth. The idea is simple but enormously powerful. The more nodes, the more powerful the system becomes. Distributed peer-to-peer network. These networks consist of individual computers, also known as nodes or peers, which make their computational resources directly available to all other members of the network without having any central point of coordination. These networks perform a range of activity, including but not limited to data sharing, asset transfer, content distribution, and privacy protections. Consensus. Consensus is one of the core tenets of the blockchain. Consensus decision-making is a group of decision-making process in which group members develop and agree to support the decision in the best interest of the whole. Consensus occurs when at least 51% of the nodes on the network have the same blocks in their locally validated blockchain. Distributed ledger. A distributed ledger is a database that is shared through consensus and synchronized across a network spread across multiple sites, institutions, or geography. Underlying the distributed ledger technology is the blockchain. Ownership. Ownership typically refers to assets. This may be property, data, digital currency, personal information such as CV, etc. In the context of the blockchain, the focus is not on who owns the asset, the current state of ownership, but rather the blockchain maintains a record of all transfer of ownership in a ledger in an ongoing fashion. Proof of work, or POW. Proof of work is considered to be what underpins the idea behind the Nakamoto's white paper, mainly because it allows trustless and distributed consensus. In the context of blockchain, proof of work has the primary function of deterring attacks. Its purpose is to verify blocks of data so new blocks can be created, to identify and remove any nodes discovered to be sending fake requests. Take a look at the steps that occur to gain consensus in a blockchain using proof of work. New transactions are broadcast to all nodes. Each node collects new transactions into a block. Each node works on finding a proof of work for its block. When a node finds a proof of work, it broadcasts the block to all nodes. Nodes accept the block only if all transactions in it are valid and not already spent. Nodes express their acceptance of the block by working on creating the next block in the chain, using the hash of the accepted block as the previous hash. Not always considered the longest chain to be the correct one, and will keep working on extending it. Proof of stake, POS. Proof of stake is another way to validate a transaction and achieve the distributed consensus. It is still an algorithm, and the purpose is the same as the proof of work, but the process to reach the goal is different. Unlike the proof of work, where the algorithm rewards miners whose goal is to validating transaction and creating new blocks, with the period of stake, the creator of new block is determined depending on its stake in the network. Proof of stake mining asks users to prove ownership of a certain amount of currency, their stake in coins tokens. Instead of buying computers and electricity for mining in a proof of work system, a proof of stake system used their capital to acquire the coin token that allowed them to validate transaction. In the proof of stake model, network security is governed by peers having a stake in the network. The incentive provided by the algorithm do not promote decentralization in the same way that proof of work algorithms do. The network can be considered decentralized because a large number of unique accounts are contributing blocks to the network by voting, and the block creation reward is earned in proportion to their stake. Trustless and distributed consensus. A trustless and distributed consensus system means that if you want to transact with someone, such as send and/or receive money from them, you don't need to trust in third-party services to successfully complete the transaction. If you use traditional method of payment, you need to trust in a third party to settle transaction, such as Visa, MasterCard, PayPal, banks, etc. They keep their own private register, which stores transaction history and the balances of each account. The common example to better explain this behavior is the following. If Alice sent Bob $100, the trusted third-party service would debit Alice's account and credit Bob's account, so they both have to trust that this third party is going to do the right thing. Within a blockchain transaction, everyone has a copy of the ledger blockchain, so no one has to trust in third party because anyone can directly verify the information agreed and written, and the transaction will occur and the relevant records updated in the new verified blocks. From myself, the team at China Direct Sourcing, the team at Freezen Technology, and the team at Blockchain Collective, thank you for watching this video series. If you like what you see and hear and want to know more about it, please subscribe our channel and contact us. Good luck with your blockchain learning journey. Enjoy the program.